So I will begin by briefly introducing the experience of the SCIFT hub and providing an overview of what we do. And then I will leave the floor to Chiara, who will focus more specifically on the work we are carrying out on the subject of urban heat islands. So SHIFT is an acronym that can be translated roughly as science, climate activism, imagination, fostering knowledge, and technology. I am aware that it sounds smoother in Italian, but in general, it is conceived as a permanent hub and a workshop with a physical location in Bologna, but also articulations outside of the city and networks abroad. And its broad aim is the appropriation of existing technology and creation of new technological tools for to apply to matters of social and climate justice. I know it sounds very broad, but we will get into more concrete examples pretty soon. Just a bit of history. SHIFT was born in connection to Reclaim the Tech, which was a conference/festival that we collaborated in organizing and hosting. It was very broad in terms of contributions across various scientific disciplines, various formats, and various international contributions. So the idea at its core was that technologies are not neutral because they are rooted in power dynamics, in their conception, funding, designing, functioning, and employment, and that we can either be passive spectators to these unjust technological developments, or we can be active and reclaim the tech. So the first Reclaim the Tech event took place in a very hot Bolognese summer, and the following summers were even hotter. So temperatures rose above 40 degrees, and during this time, we realized that we needed to act on the territory as well. So SHIFT was officially born in March 2025, but the various projects were already active before, and it includes a quite diverse multidisciplinary group. So some of us are academics from scientific or humanistic backgrounds. Others are people working in the fields of science and technologies, and others are activists and amateurs. As a permanent hub, SHIFT is constantly evolving, so we have projects that are just born and projects that already have results but continue to improve. Just to quote some examples, we work on AI and algorithms for activism. We question how to develop alternatives to traditional proprietary platforms. We also have a project working on possible uses of drones, which is inspired and collaborating with the project Drones for Good by the University of Padova. And we apply the same approach to 3D printing. But more interesting for this presentation is the different projects that we are carrying out on developing technology for grassroots climate justice, especially by monitoring the city. This means developing tools that allow, on the one hand, to assess the impact of extreme events, and on the other, to carry out constant preventive monitoring of changes in the urban structure that contribute to causing these events. Our methodology is grounded in the principles of extreme citizen science. So we want to actively engage citizens and local organizations in collecting and interpreting data while we raise awareness about urban and climate-related issues. So one example of such engagement is the group bike ride that we organized this July, where we crossed various neighborhoods in Bologna carrying meteo trackers on our bikes to monitor differences between temperature and air quality in various areas of the city and neighborhoods. But this is just one example. One of the projects we carry out on climate justice has to do with noise pollution related to the Bologna airport and its impacts on public health. And as you can imagine, we work with pre-existing public data, but also we need to develop new tools and models for collecting and interpreting this data. And this same logic applies to the monitoring of urban heat islands, which will be the focus of the remaining part of this presentation. So I will now leave the floor to Chiara, who will go more specifically on the subject.
Thank you, Laura. So yes, about specifically on urban Thailand, as we also saw in a previous presentation, is an urgent matter and is also a structural problem that affects our cities. So we try to, but the thing is that there are plenty of data open available to map to try to address this issue globally. So we try to address this issue by developing a global applicable algorithm based on only open data that lead us also to this publication. So this the workflow that was developed in an open in R, that is an open language, and then was also translated into Python to improve accessibility to a broader scientific and coding community. Is based on this different type of data. It uses Landsat thermal band and OpenStreetMap to unveil the land cover map. So to take the urban area and the rural area is because of course urban Thailand is based on the thermal differences between these two type of land covers, but also a digital elevation model. So all these data are automatically downloaded for the area of interest requested by the user. And all the rest of the workflow is also automatized. There is a pre-processing, so the thermal bands downloaded from Landsat that, of course, suffer by cloud cover, for example, or other low-quality pixel are masked out, and then all the proper scaling offset are applied to get a seasonal mean land surface temperature map for the city. And then by taking the difference from these two areas, we calculate the urban Thailand, but not only. This is employs also the digital elevation model because not only the air temperature but also the land surface temperature is correlated with altitude. So to avoid to insert the over or underestimation of this phenomenon, we take into account also this data to ensure that this can be applied in any city of the world. And then we also apply the normalization that gives us this surface urban island index. So that goes from 0 to 1 to have a more easier interpretation of the map, and also we can compare between different cities or even the same cities but in different years. And all the code is open and is available to anyone on the GitHub platform. So the scope was to make all these data that are there in the website are open. These usable by anyone, by activists, by public administrators, and all the people to lower the technical expertise. And finally, also, there is another addition of the tool that is the computation of the distance to green infrastructure based on the 300 rule to improve the neighborhoods. Because this being all developed in an open language, it is very flexible tool that can be also improved further. Here we can see just a few examples of some cities where we applied the algorithm. And also we try to compare with the different with a different the cities at different latitudes, and is one result that is immediately seeable is that the cities at mid latitudes are the less suitable and adapted to the climate challenges. While where the climate is hotter, the cities are already more built in a way that can suit to this topic. So just to give it a try, now I move to the R platform. So here is once one just go to sorry, okay, to the GitHub page. Here is the where it is stored the repository of the code. Anyone can just download the zip of the code, and there is also an explanation of how it works. Please, if you use it, remember to fill the feedback form in order to give us the possibility to improve the algorithm. And then we can open it with RStudio. And first, all the the user just need to modify these three parts that are described here. So one just needs to put the city of interest, a local folder path, and another folder path where there is this script saved in the local folder. But and then, of course, the first time it will install all the required packages. But then from the time on, it will be just once modify this part, you can select all this part and just give the run button, and all the things will be automatized. So then we will have, for example, I give this. So this is my local folder path. And in this folder, in this case, I tried on Bolzano. There are three, it automatically built also the folder structure. And in the output folder, I already make give it a run because it takes about 20 minutes that if, of course, now we don't have. But first, it will download from OpenStreetMap the land cover layers, so administrative boundaries, but also the rural areas and urban areas. Then the Landsat collection and the digital elevation model to get the altitude. And then it will process first the land surface temperature average for the last available warm season, depending on the hemisphere and the Copenhagen climate zone. And after that, it will also arrive to this SUI map, and all the output are available both in the folder, in the output folder, and also we have also a visualization directly on the
1 minute.
Okay. Yes. So that's it. I give back the floor to Laura.
Yeah, I'll just conclude very quickly by saying that, first of all, one of the advantages would be to build tools that are applicable not only on our city, but also everywhere, but also tools that can be modified and improved through feedback and the intervention of other people who are maybe expert in other similar aspects or work on similar fields. And this is why we also value participating to conferences like this. So because of how much technology is relevant and how many projects exist that work with technologies for grassroots climate justice. We just want to invite everyone who is interested in working on a similar field to maybe get in touch with us or share their experience. And that is just it. Just thank you for